what is a rough surface? Where to bring rough surface? I think you put any blanket or just go to the bedroom now. So release that pen or pencil. You can try no, you can try it. So I think that'll be rough enough, no? So what will happen to the end A? If the friction is sufficient, what happens? The end A will not shift. If it's smooth, if it's on dining table or glass or on the tile, granite on the floor, if you release the rod in this position, as the end A will shift towards left. Here what will happen? Because of rough it's telling it will not shift here. So for that is asking, will not slip. Its lower end will not slip if the friction coefficient between the rod and the ground is greater than. So he's putting some conditions. Therefore, certain value of mu is there for which it will not slip. That value of mu is what is asking us to tabulate. If the mu is less than that, it will slip. And greater than that, it will not slip. Now, already I think we have covered enough background, how to assume the direction of friction. Okay, let's get into the problem. The free body diagram here, this is mg. First, we'll show all the forces. This is Ny. How the friction must act towards right only. You should not ask me why towards right. These are the forces that are acting. Now tell me like about what point it will rotate. Really, I'm troubling you a lot now. About what point it will rotate? About center of mass or about point A? Anybody wants to answer? Okay, you can unmute and tell me. You want to reply back? Okay, I'm very happy to hear your answer here in this case. Will it rotate about center of mass or about point A?
Point A.
Point A to
Point
rotate.
A, sir.
Okay, fine, all of you. About point A only. Because you just take the pen or pencil, just release on the bed sheet, no? So the point A will not shift. And you can see all points are rotating about point A. So where alpha A, I should write it. This alpha is what I have to show here about this particular point. Getting no smooth, rough, things have changed here. Now let's write the equation. Now what is the type of motion it will describe? Rotatory motion, only rotatory, both rotatory as well as translatory. Only rotatory, no, it's a fixed axis rotation. The rod describes fixed axis rotation. So I'll write it nearby, the rod. Okay, now get into the thing, this one. This is, write the equation. So now this will have tangential acceleration, AT. Let's write all the possible equation. First, torque. Torque will be due to the weight. First, we'll calculate the torque acting. So mg L by 2 cos theta should be equal to IA alpha. If you want, you can write only alpha A. Let me write only alpha, that one. So mg L by 2 cos theta ml square by 3 into alpha. Alpha will be 3g cos theta by 2L. Keep it this one. There's equation 1. Then what about the tangential acceleration? AT equal to L by 2 alpha. So this should be So L get cancelled. So this will be 3g cos theta by 4. So this is a tangential acceleration. And then we have to, what's the condition? That particular mu and theta, how they are related. That was the thing, no? How mu and theta are related. That equation has to be determined. So along x-axis, friction force is acting, no? Along x-axis, the friction force will act. So this angle will be theta. So therefore, shall we write here F into F is equal to max. Any other equations? And what is F? F should be equal to mu n. And AT value we know. I'll write it here. Mu n. AT value 3g by 4 cos theta sin theta. So this is equation 3. Finally, we have something equation like this. 3mg sin theta cos theta by 4. Along y-axis, mg minus n minus ny should be equal to mat cos theta. So value of at we know. So I think now substituting 4 in 3, ny will get eliminated. That then solving for mu will get the required answer. So the value of p will come equal to 3. Huh? Check this one. This will be our answer. How to interpret this answer? How to interpret this answer? If there is no friction, as the point A will shift towards left, no? Because of the friction, what happens? The point A is at rest here. So then, if the value of mu is less than this value, what you calculate the mu, if it is less than p by 2 sine 2 theta 1 plus 3 sine square theta, there will be slipping. If mu is greater than this, there won't be slipping at point A. Now, what we have released? Rod. So what I can release now? I can release any other rigid body. So honestly, do try not getting take help of teacher. I think it's all about calculating moment of inertia, the headache. Rest all everything you know how to manage. So instead of this, let it be semicircular plate now. What should be the value of mu so that it will not slip? Go back to the previous problem. Here only, you make this surface rough. Then what should be the value of mu so that it will not slip? In that case, it will rotate about point P. Come for here again. What should be the value of mu so that it will not slip? Fine. So again, take the cone. So you're going to release the cone. Just do at least for 3 different objects so that you'll get a generalized picture. Rod, semicircular plate, triangular plate, hemisphere. So of this one. So that'll be enough. So overall it'll be better position. Okay, well, other objects are there, so you must work out the same thing. What is orientation? You can put any any orientation. I think for say again, so some can it triangular plate, can it slip now if it is like this? If I release, will not slip. No, why it will slip? It will tip. That's all. It will fall. That one. So again, you should be very careful enough whether it will tip or not. But slightly, if you do orientation like this and release, yes, it will tip. Try this at home. Check it. Huh? So the orientation also very important. So it's a semicircular plate. Earlier we took that one. So here it will not, nothing will happen. Here it can, as the friction will act. Here friction will not act. let's same in order. I'm asking this question now. You do one thing. I think you are at